Hi, fifth graders. Today we're going to start talking about decimals. And learning about decimals is one of my favorite things to do within the year because decimals are so important to us in everyday life. We see them all over the place, like in price tags when we're looking to buy something. They're represented at gas stations advertising the cost of a gallon. We see them on scales when you're weighing or measuring something, or in soap or cleaning or shampoo bottles when it tells you how much is in it. And yes, most importantly and most exciting, decimals are used all the time when we're talking about money. So, as you can see, it's really important to understand decimals because we use them in so many different ways in our everyday life. So, let's talk about what a decimal number really is. A decimal is just a number that shows part of a whole. For example, if I have the number 8.54 or 8.54, that 8 that comes before the decimal point represents a whole number amount. But that 54 that comes after the decimal point represents part of the next whole number. In other words, I have a little bit more than 8, but I don't have 9 yet. I have a little bit of that next whole number, but not all the way to the next step. Now, you might be surprised to find that whole numbers can actually be written as decimal numbers as well. For example, if I take the number 96, I could write that as 96.0 because just like in 8.54, the part before the decimal point, the 96, represents the whole number amount, and the part after the decimal point, in this case the 0, tells me the part of the next whole number. Now, most of the time we don't show whole numbers with decimals because we don't really need to explain that there are no parts towards the next whole numbers. But I wanted to mention this now because later on in our unit, it's going to be really important for us to remember that every whole number actually has a decimal point on the end of it. So whole numbers are decimal numbers in disguise, but we just don't often write the decimal part. Now, this year in fifth grade, we are going to be learning about three new decimal place value positions. And decimals are another one of those times where we get to stretch your thinking. So, all along, up until this point in your math career, you have learned that the smallest place value position was the ones place. And that has served you fairly well up until this point. But now in fifth grade, we're going to learn that there are actually place value positions that represent an amount less than one whole. This year, you are going to be responsible for learning the first three decimal place value positions. One spot after the decimal point is called the tenths place. Two spots after the decimal point is called the hundredths place. And three spots after the decimal point is called the thousandths place. We'll talk a little bit more in another video about some memory tricks for how to remember exactly where those place value positions are. Just like we get to stretch our thinking with a place value chart, we also get to stretch our thinking in how we use base 10 blocks, because base 10 blocks can now be used to model decimal numbers. Let's take a look at some examples of how we can use base 10 blocks to model decimal numbers.
Okay, so all along in your math career, you've been able to use base 10 blocks to model different whole number values. Your ones cube has been modeling 1. Your blue rod has been modeling 10 because it would take 10 of these small cubes to make up one blue rod. And your yellow flat has been modeling 100 because it would take 100 of these cubes to make a flat or 10 of the tens rods to make a flat. Well, now we're going to use these base 10 blocks a little bit differently. Instead of the orange cube being used to model one whole, now your yellow flat is going to model one whole. And since it takes 10 blue rods to make up one yellow flat, that means that when we're using base 10 blocks to represent decimals, the blue tens rod is going to be equal to 1/10 because it's 1 out of 10 pieces that would make up your whole flat. And if the blue rod is 1/10 because it takes 10 of these to make up a flat, that means your orange cube is now worth 1/100th or 0.01 because it would take 100 of these small cubes to make up a flat. So let's say I wanted to model a decimal number. For example, maybe I want to model the number 2 and 43/100ths. Well, I know now that my yellow flat is equal to 1. So I'll start by putting 2 yellow flats on my paper to see the whole number amount to. The 4 is in the tenths place, so that means I'll need 4 tenths rods. And finally, the 3 is in the hundredths place, so I would need 3 hundredths cubes. Let's take a look at one more example using the blocks. This time, I'm going to model the decimal number 3 and 5/100ths. Now, I still have a digit in the ones place. This time it's a 3, so I'm going to put 3 of my yellow flats down on my map. But this time I don't have a digit in the tenths place, so that means I'm not going to need to use any of these blue rods. Instead, I can move right to the hundredths place. Since the digit 5 is in the hundredths place, I'll model this decimal with 5/100ths cubes. So that's how you would model decimal numbers using base 10 blocks. Now there is one decimal place value position we can't model using the blocks, and that's the thousandths place. That's because a thousandth would be 1/10 of just one of these little orange cubes. Now, I wouldn't be able to slice this into 10 tiny slivers and still have a piece that was easy to move. So I'll show you what this looks like on paper in just a second, but the way that we'll represent that is we'll take that cube and we'll zoom in on it, and we'll show a grid with 10 sections. And then however many thousandths we have would have that many of those little slivers shaded in, because this is showing that it's taking 10 small slices to make up one cube. Let's take a look at what this will look like in some picture examples.
Now, of course, you won't always have the actual base 10 blocks in front of you, so you might see them represented by a picture. So your flat will show you 1, your blue rod will show you 1/10, your cube would show you 1/100th, and then this is how that 1/1000th piece would be represented. So when we said we could take that cube and slice it into 10 little slivers, this is how it would be shown as a thousandths piece, almost like you're zooming in on this one little cube here. So let's take a look at two quick examples of how you might see a decimal number modeled. So for example, you might see a grid that looks like this. So you'll go through and you'll figure out how many tenths rods are colored in, how many little hundredths cubes are colored in, and then if it zooms in on any of the thousandths, how many little strips or little slivers do you have? In this particular grid, we see 0 whole amounts. I don't have any full flats. 3 long rods representing 3/10ths, 9 small hundredths cubes, and 2 little thousandths slivers. So this grid is representing the decimal 0.392 or 0 and 392 thousandths. Let's look at one more together. This time, we have a grid that again has no full flats colored in, but we also don't have any long tenths rods. That means we're also going to have a placeholder 0 in the tenths place. We have 3/100ths cubes filled in and 9 thousandths slivers. So this grid is representing the decimal 0.039 or 0 and 39 thousandths. We'll do lots more practice with this, but hopefully that helped you understand the basics of the tenths, hundredths, and thousandths place and a couple of the ways they can be represented.